This project was designed to conduct one of the passive natural ventilation for two case studies, one in London and the other one in Dubai, as to evaluate the impact of the site orientation and to compare the results of the base model with the stack effect strategy implemented in each city. Finally, conduct the comparison between both cities as to recommend applicable strategy for the successful scenario. Multiple softwares included the IESVE application being used through the process of the analysis. The project being developed by Hadeel Alkhateeb and Huda Almansoori.
For better natural ventilation, buildings need to have openings on its envelope and cooling its inner spaces. In this project, adopting one passive natural ventilation strategy was implemented at London case during summer season through cooling building inner spaces. On the other hand, it's adopted in Dubai case during winter season through warming inner spaces. Usually, to allow the best ventilation, it's necessary to study the following parameters as to get the best of the passive natural ventilation: windows availability and sizes within building design, the surrounding built environment as to assess the wind direction through building orientations, implementing stack effect for multi-floor buildings. The project is designed to test a surfaced apartment hotel with G+4 levels. Building design and geometries as the following: designed as half olive shaped from one direction and the opposite is rectangular. Total floor area is about 3,000 meters square. Total building height is 20 meters as 4 meters per floor. Each floor included only one surfaced apartment with one lounge room in the olive-shaped side and some additional rooms. The frontage has a glassed reception with greenish.
At the early beginning, we've studied the advantage of natural ventilation and its criteria. So the natural ventilation not generated by any type of supplied energy or even installed machines. However, it's directly generated by supplied fresh air. It requires a window built into the wall. The size of the window usually designed in relation to the floor area or volume of the room. So no energy to be generated, so it's completely passive and no noise hazardous there. Least maintenance might be required and economically it's feasible as less capital needed for natural ventilation. The model designed in EISBE and the analysis covered only lounge at ground as well as fourth floor since it has many windows and connected directly to the left, which is also act as a shaft on the study in order to study the effect of the stack. These are some forms of stack effects design considered. Right image describes how the strategy is used in London model at summer, which shows that the hot air enters the upper stack towards upper lounge room from the shaft and then goes down to lower room till colder air, which is heavier, leaves the building from lower level windows, and opposite ventilation and stacked effect was designed for Dubai case study, especially in winter season described in left image. A flow design software was used according to the wind velocity as to select optimal orientation. This is conducted only for Dubai as an example, and it shows that the southern orientation in Dubai is the optimal since the wind velocity surrounds the lounge room is around 4.3 to 5.5 meter per second, which is higher than the northern direction for Dubai. Building component being checked within the software in a specific external wall material as well as installing the minimum building internal load such as people occupancy by time, lighting, computer usage and room conditions when switching off heating or cooling system. First of all, we conducted London model and the location selected on Horton Town, which is 2.8 km away from Heathrow Airport, and the area is a mixed use with lots of residential districts and considered too greenish compared to Dubai case. It's also close to the logistics area of the airport, about 90 meters away, and this allows for better business opportunities for the hotel visitors. And about 95 meters from Boyle Park, as well as it's very near to the vicinity of Raspberry Reservoir Lake. Climate table for London case was generated from ASHRAE database. However, we have validated it through the Heathrow Airport data for the climate. According to the application, we have generated climate data and checked it again for Dubai versus London to check the coldest months for Dubai as well as the warmest months for London. Simulation also covered the suncast, which shows shade situation for the building in the highest wind velocity and tested for the London 3 warmest months. This is the solar exposure simulation results, and this is according to the model. A chart shows the total energy when switching off heat system in London summer season. Since the highest wind velocity in London was 11th September at 17 p.m., it's been considered through all the scenarios. First scenario was developed for London according to the base year. The base year model conducted with no strategy. All partitions were available while testing for both upper-lower lounge rooms. According to the results, bottom room is considered cold since the air temperature within the half-meter height is between 22.5 to 23.4 degrees Celsius. Air goes inside bottom room from the window to its middle, stopped by the partitions, and moving again within the warmer air towards the middle spaces. However, the upper room is colder than the bottom one. The following scenario is conducted with a stack effect. Left area is considered to be a shaft, and in the top of the shaft at the roof there was windows to allow for warmer air to go inside the shaft distributed within the upper room. Hence it's been analyzed twice, once with the partitions and the other one without partitions in the lounge room. This scenario concluded that the effect is barely noticed in the ground and upper rooms since the partition available, although the top stack provides hot for air to be circulated in order to warm the room, still the partition considered a barrier for the air to warm other spaces in the room. Hence, partitions being removed, and after re-evaluation the lower room, it became quite colder. Shaft windows allow for better circulation, better cold and warm air. In second scenario, the integration for the previous one was implemented and the stack effect tested after elevating the ground floor room and to provide windows in the bottom at ground. Due to the elevated bottom lounge and non-distributed ground floor, which we redesigned it as to become a lobby only, in order to allow easy ventilation in the shaft between cold and warmer air within the ground floor. The ground floor designed with no partitions, no blocking walls, no heavy furnish, and more opening spaces with some greenish to allow for better lobby breathing that moves colder air from the lobby to the shaft to the bottom lounge room in order to warm it. Actually, bottom room is mainly colder than the shaft area, hence air flow entered from the shaft. Eventually, ground lounge room temperature ranged between 19.9 to 20.8 degrees Celsius. From second scenario, we again tested third scenario with the changes in the hotel orientation, adopting same previous criteria and operation as to check if there is more enhancement on stack effect among the hotel in London. So it's assumed that the orientation changed from 90 degree up to 270 degree from the northern direction of London, which is the eastern direction. Accordingly, the bottom room temperature was checked again. It's obvious that the change in the orientation did not improve the room's warmness since the wind direction was the same towards the hotel. Room's temperature were exactly the same, as well as the shaft temperature. Overall conclusion, and according to all findings and analysis stated for London model, we concluded that the base model lower room temperature is ranged between 22.7 to 23.7 and upper room temperature ranged between 22.6 to 23.5. Within the shaft, the cold air stuck and not exchanged within the lower or upper rooms. However, for the stack effect strategy, it is successful with no consideration for the different orientation since it's restricted to the study area due to lake vicinity to the site, so it's either northeastern or northwestern, and both generates almost the same result. So the lower room temperature ranged between 19 to 20.7, which is really lower than the base model. Upper room temperature is 22.4 at the maximum, which is less than the base model about little, and the colder air within the shaft goes out to the bottom room and exchanging the room temperature, so it gets colder than the upper. Overall results shows weakness in cooling the room as the cold air is stuck in the shaft for the base model, with no circulation allowed between both shaft and rooms. In conclusion, the rooms in the base model stays warm with natural ventilation. Thus, only recommendation is to close always the doors connecting the shaft with the upper lower rooms and changing the direction of window openings by opposite to wind direction in order not to allow for hot air to enter inside rooms. This is for the base model. As for the stack effect strategy, which is implemented in the London model, since the excellent cool air goes inside the bottom room as the cold air shifted from the shaft to the bottom room due to better air circulation, both orientations allows for shaft to act like a cooling system through its inner circulation. In conclusion, for this strategy, the bottom room only gets excellent coldness in summer than the base scenario, so stack effect can be implemented along the specified orientation.
Before we started to model Dubai in the software, a site visit have been conducted in order to feel some sense of place and to survey the whole area as per shown in these photos. The area neighborhood is considered to be mixed use and it is considered to be fully serviced by community facilities within a short distance, such as schools, nursery, garden, masjid, and many retail shops. Hence, it's considered a livable area for local community. For studying area, the first location was selected is to be within 0-degree northern orientation, while the selected location was the second one with 180-degree northern orientation. This is the design weather data from Dubai International Airport climate information which considered in the software. This suncast analysis displays the shade exposure assuming the coldest day 21st for each month of November, December, and January for the hotel and its neighboring buildings. This chart shows the total energy over the year with switching off the air conditioning in winter. According to model analysis for the weather, this chart shows the highest wind velocity per each month. Among all, the highest is considered on the January 21st. For Dubai base model orientation analysis, without natural ventilation strategies, the lounge room at the ground floor is considered colder since the air temperature by 1.5 meter is between 23 to 25 degrees Celsius. Air moving around the lounge room from its window directions to its middle, but it stopped according to the partitions and moving again with the warmer air towards the middle spaces. Hot air goes through the shaft towards the upper level and again circulated within and goes down again with colder air, though there is no chance to allow for warmer air to go back to bottom lounge room and warm its temperature. In the fourth floor lounge room, the cold air stays the same and not has been changed by warmer air. First scenario, Dubai model with orientation with without lounge room partitions. Effect is barely noticed due to small size of opening between the shaft and the room. This shows that the hot air is moving towards the top of the shaft and that the cold air goes down again. Upper floor is warmer than the bottom lounge room due to having windows connected to the stack shaft. Second scenario, Dubai model with stack effect and elevated ground floor. Warmer air in the bottom of the room comes from the below windows openings that were implemented after upgrading the ground floor to the mezzanine level.
In the bottom of the lounge room, the air temperature is 24.2 degrees Celsius. Upper floor. This is upper view for the upper lounge room, which shows it's colder than the bottom one. Still, this scenario needs better design to allow for warmer air to be generated within the shaft and then exchanged within the rooms through the windows. Third scenario, Dubai model with stack effect, elevated bottom floor and enlarging shaft openings at the ground, changing the size of windows designed within the shaft area and enlarging the opening size to allow more volume of warmer air to be generated, caused that the bottom room gets warmer than the previous scenarios, especially within the zones connected to the shaft. For upper floor, more warmer air generated within the top of the shaft, which goes to the bottom to be exchanged within the bottom lounge room, lead for better warming air temperature.
According to all findings and analysis stated for Dubai model, we concluded that in base model, overall results shows weakness on heating the room as the warm air stuck in the shaft with no circulation allowed between both shaft and rooms. In conclusion, the room stays cold with natural ventilation. Thus, only recommendation is to open the doors and existing windows within the rooms. However, for stack effect strategy with orientation of 180 northern direction, better warm air goes within the bottom room as the warm air shifted from the shaft to the bottom room, hence better air circulation. Enlarge the size of windows as well as provide more spacing for air circulation through moving furniture which may disturb the circulation. In conclusion, the bottom room only gets warmer in winter than the base scenario, so stack effect can be implemented along the specified orientation and creating better opening.
As to conclude, the scenarios conducted for Dubai and London models, the overall conclusion and recommendations is the following. Adopting passive natural ventilation stack effect strategy with London case ends up with the successful results on cooling more the bottom lounge room during the summer season, and it will be highly get better into consideration to the allocation for either northeastern or northwestern, whereas adopting stack effect strategy in Dubai case ends up with a slight improvement in warming the upper lounge room with specified design criteria included window opening size orientation, hence it's not recommended, though it's architecturally recommended to select eastern direction for construction, no partitions required within the lounge rooms, and creating bigger openings windows could help to at least keep the warm weather inside the lounge room if we are not going to adopt any stack effect strategy for Dubai case. Eventually, implementing strategy is highly recommended in the future in London with the consideration of redistributing the furniture within the room to allow colder air circulation. However, for Dubai, it's more feasible not to implement it as it needs more studies for other natural ventilation strategies.